All right, so we're starting into notes here, Jeff, if you want to, follow along here. Too funny. All right, so first kind of inequality we're going to look at, absolute value inequalities. Okay. And before we guess, question.
The graph of any inequality of any function is just like the line, and then the solutions are either inside or outside of that line.
Yes. So that would be like solving an inequality when we're talking about like two variables. But for the one we're looking at right now, we're going to be just in a single variable. So all our solutions will be
On the line?
one-dimensional, just on a single number line for absolute value inequalities. And then we talk about the quadratic inequalities. Well, same thing. It's all going to be just solutions on. It's going to be one-dimensional, so just one variable. So it won't be like y equals something or y greater than something or y less than something. It'll just be. You'll see. It'll make more sense here. These are just going to be single dimension. They're a little more simpler potentially. So we'll see here. But before we talk about absolute value inequalities, I want to refresh our memory here about what absolute value is. Okay. When you take the absolute value of something, what is it? It is the distance from zero. Exactly right. Okay. Most of the time, we just kind of remember that as distance. It just makes things positive, right? But really, it is distance from zero. And since distance is never really measured negatively, all right, on the number line there, then we end up with making things positive, right? Okay, so distance from zero on the number line there. Okay. So we'll just do like a couple like brief, kind of introductory things here to humor me. All right, so we'll start with an equation, right? Absolute value of x equals 3. So in other words, when you see the absolute value symbols, one way you can think about this is the distance of what number, right, x there, the distance from 0 of what numbers gives you 3. And so what numbers have a distance from 0 of 3? X equals 3 and x equals negative 3, right? Exactly right. Okay, and that's why we have two solutions, because there's two numbers on the number line whose distance from 0 is 3. Okay.
Those would be the solutions because the actual graph is translated down 3 units.
Yeah, you could think of it that way. Yes, if you like subtracted 3 on both sides, there'd be equal to 0. Yeah, I see what you're saying there. Yeah.
And then since it's just basically y equals x on both sides, it would just go up to the left and hit negative 3, and go up to the right and hit 3.
Exactly, because the slope would be 1 or negative 1 on the other side. Yeah, that's true. Okay, that does work. All right, so now we're going to throw in an inequality, though, right? An inequality. Absolute value of x is greater than 3, and this, even though it looks so simple, right, it gets a little bit trickier here because we're like, whoa, okay. So, but still, if you think about it in terms of distance, it can make more sense to you, okay? So we want the distance of our number here to be greater than 3 away from 0, okay? So on a number line, right, if we just think about this, so I'll just draw a little sketch here for us. So there's 0 and 1, 2, there's 3, and 1, 2, 3 in this direction, okay? If we want to be greater than 3, right, so again, absolute value is distance from 0, and we want our numbers, our solutions, their distance to be greater than 3 away from 0, okay? Well, if we want to be more than 3 away from 0, we can go out 3. Here's 3 away, right? 1, 2, 3. But if I want to go more than 3 away from 0, I need to say greater than, less than, greater than, equal to, less than, equal to, what here? Greater than, right? So I want to go, I'll start here, and I'm not going to include it because you don't have the equal to sign there, and we'll just go this direction, right? But that's not the only way that we can go 3 units distance from 0, right? We can also go 1, 2, 3 units in this direction. And if I want to go more than 3, which direction should I shade here? Yeah, less than, or to the left here. Exactly right. So.
Hey, this isn't the same quiz as you gave me yesterday.
Yeah, I gave you that's an old quiz I just had still, so I wanted to return that to you.
Oh.
That's all. Yep. Okay. So now I've returned all the papers for the people that are here. So how do we write this? Well, x is greater than 3, x is less than negative 3. Okay. And then to join them together, we're going to say or. Okay. We cannot write this statement as one inequality because we have these two kind of like disjointed answers. One set of answers is going one direction, one set of answers is going the other direction, and never the twain shall meet, right? So they're separate and they will stay separate. So we don't have any like overlap. All right. But there we go. Our solutions. All right. And then let's do one more here, one more simple one. Absolute value of x is less than or equal to 1. Okay, absolute value of x is less than or equal to 1. So we want to, again, come up with the solutions here. Okay. Well, again, I'll draw a number line, maybe to help us figure that out. So here's 0, there's negative 1, there's 1. Okay. Now we want our distance to be less than 1, less than or equal to 1 away from 0. So equal to 1, that's easy. That means either we want to be negative 1 or positive 1 again, right? Because both negative 1 and positive 1 are 1 away from 0. But to be less than 1 away from 0, okay, we'll start at 1, and then to get more solutions, do I want to go to the right of 1 or do I want to go to the left of 1? To the left, right? Yeah, less than it. But, yeah, we want to stop at the negative 1, right? Because we don't want to go any further away from 0 in this direction. And so we just have this piece, okay? And so with this kind of inequality, right, you can write it as one gigantic inequality like that if you'd like. Or you could also write it as two separate inequalities but joined by the word and, okay? So either one of those is fine. Either one is fine. All right. So that's kind of the concept behind these kind of problems, right? That's the concept behind these kind of problems here. So let's maybe try one that's a little bit more involved, but not by much. Not by much. Okay. Ooh, let me think here. Actually, I kind of want to, sorry folks, I'm going to add in a little piece over here. We'll do something like, I don't know, plus 2 is less than or equal to 6, like that. Okay, just so I said it. Sorry, I want to change that just a little bit here, just to show something. All right, so got an inequality, right, with an absolute value in it. All right, what we want to do here to solve this, before we try and break up our absolute value, okay, because again, here we took our absolute value inequality, we broke it up into two inequalities. Here we took this absolute value inequality, broke it up into two inequalities, right? Okay. This one, before we break it up, what you want to do is isolate the absolute value first. Okay, bless you. So, to isolate the absolute value here, what we need to do to both sides. Right, exactly right. Subtract 2, right? Okay. And that would go for anything, right? If you had like a coefficient in front of the absolute value, you want to subtract 2 and then divide by whatever that coefficient is. But you want to isolate this absolute value before you then break it up into the two inequalities. So yeah, we'll just do that real quick here. I just wanted to show that. Okay. And now that we have this thing, and again, don't fret too much by the fact that, oh, Mr. Wood, we have x plus 3 in here before we just had x's, right? The idea is still the same. The idea is we have the distance of this thing, right? And this is a more complex thing than just x, but it's fine. The distance of this thing we want to be less than or equal to 4 away from 0. So how can we denote that? Well, x plus 3 is less than or equal to 4, right? That's one way, okay? And x plus 3 must be greater than or equal to what other number? Negative 4, right? Because negative 4, right, is on the other side there of the inequality, or of the, of the distance from 0 there. Jeff, do you have a question, or are you just going to answer that?
Yeah, I was
Okay.
just going to say -4.
Okay, thank you. Good. Exactly right. All right. So finish solving here. Subtract 3 on both sides. Subtract 3 on both sides. Okay. Yes, Ro.
Is it when you're dividing or multiplying or something like that when the sign switches?
Right. Okay. So yes, it is when you are multiplying or dividing by what on both sides that we flip the inequality sign around. A negative. That's right. Okay. And there's like kind of like a logic behind that. It doesn't just like what I want to say. It's not just some like rule we just came up with. It happens kind of naturally. If you start with a very basic, and I'll just do this little quick aside here. Okay. If you start with a very basic like inequality, right? 2 less than 3. Is 2 less than 3?
Yes.
Yes, right? And if I were to, like, for example, add 1 to both sides, right? 3, is 3 less than 4? Yes. And if you were to add a negative 1 to both sides here, okay, now you'd have, is 1 less than 2? Yes. Okay, so adding positive or negative numbers, which therefore is really like subtracting positive or negative numbers, doesn't change the truth of our inequality, right? It still stays true, right? So the doing the same thing to both sides rule for addition and subtraction still applies, right? But if we take that true inequality and now we talk about multiplying, well, let's multiply by 2 on both sides. We get 4 is less than 6. Is that still true? Yes. But if I throw in and make it negative 2s that we multiply by on both sides, is negative 4 less than negative 6?
No.
It is not, right? And how do we fix it so that it is true? You got to flip that inequality sign around, okay? So this idea of flipping the inequality sign around results from taking, some of these more simple inequalities that we know must be true and just seeing what happens when you multiply both sides by a negative number, okay? In a sense, with equations, the same thing holds true. If you you could think of it that way, right? If you multiply both sides of an equation by a negative sign, we could say that we flip the equal sign around. But when you flip an equal sign around, what do you have? An equal sign still, right? So that we are technically flipping the equal sign, but equality, right? Equality is a different kind of relationship than less than or greater than, and that's why with the negatives it affects the less than, greater than stuff, but not the equation so much. Anywho, all right, different kind of relationship. Maybe more than you cared to know about this morning. Just get on with it, Mr. Whitmire. You got it. All right, here we go. So we're going to graph this real quick, just because we can. So let's see here. I got to go from negative 7 to 1. So let's see, negative 8, 7, 6, 5, 4, 3, 2, 1, 0. Blast off. 1, 2. Okay. And again, the clue here that I'm going to have an and inequality is because I want to be less than or equal to a certain distance from 0. So in this case, less than or equal to 4. So that means I've got to be, between two numbers, and which is the negative 7 and the 1 there. Okay? And so then we'll just kind of draw our two closed circles, right, and then connect between. Okay. All right. Let me have you guys try one here. Any questions on that, actually, before we move on? No? All right, so you guys try this. All right, so again, solve/graph the solutions. Okay. Solve/graph the solutions. I'll kind of make some room over here. Absolute value, 2x plus 3 is greater than or equal to 7. Okay. So go ahead, give that one a try. Okay. Absolute value 2x plus 3 is greater than or equal to 7. Give that one a try. See what you can come up with. one branch of it, yep, but there should be another branch over here as well. Yes, yeah, you can figure out for the negative one too. Oops. Paper move. There we go. All right. So, Brendan, did you get an answer for us here?
Yeah.
What'd you get for your inequalities?
So I got x is less than or equal to 2.
Okay.
And I got x is greater than or equal to -5.
Okay. I see. You are very close here. Your inequality signs are flipped around. So it actually should be less than or equal to -5. X is greater than or equal to 2. Okay. And the difference here, right? The difference here is because of we have our absolute value isolated.
Oh, it's greater than 7.
Exactly. There you go. Yep. Exactly. So we want to be more than 7 away. So we have to watch those signs. So yeah, the way we break this up then, right? We want that 2x plus 3 to be greater than or equal to 7, right? We want to be more than 7 away in the positive direction. But we also want to be less than or equal to -7 away, right? We want to be -7 away in the negative direction, right? And even further in that sense. So less than or equal to the -7. And so yeah, when you solve here, you get x is greater than or equal to 2. And when you solve here, you get x is less than or equal to -7. Okay, and again, this would be an OR inequality because, again, if we're trying to be more than 7 away, we're going to go off in one direction, off in the other direction. They never meet, right? They're going to be separate, okay? And so, well, you get the idea of the graph here. All right, so let's see here. 6, 5. Whoops, did I say 7? I should say 5 there. My bad. Fix that. There you go. Yeah, sorry. 6, 5. 4, 3, 2, 1, 0, 1, 2, 3, 4. Okay. And so then dots filled in at both of those, right, because we have the equal to, and then we'll go greater than or equal to 2, and less than or equal to -5. Yes, go ahead, go for it. Okay. So, the, one thing I want to say here that can kind of help some folks too, if you're like, if you're one of those people that maybe would like to just have like a way to easily remember, okay, how do I know if it's going to be an and inequality that, kind of joins together or an or inequality that goes two separate directions, how can I do that? There's kind of like a little, way to remember here. If you have the greater than symbol, okay, you can think of this as great or than, okay? So the greater than symbol tends to lead to those or inequalities where they go in two different directions, okay? And then if you have a less than symbol or less than or equal to, you can think of that as less than d. Okay? And that can maybe help you remember it too. Okay, that's another way to do it. Of course, there's no understanding of why they are the way they are. That's what I was trying to help us practice before that. But push comes to shove, if you need to know it, there's a way to help remember. Great or than, less than. Okay? Maybe that helps. Okay, so let's move on then to quadratic inequalities. Okay, and so we'll just solve for all values of x. Okay, so for example, 2x squared plus 5x, we want to know when that will be greater than 12. We want to know when that will be greater than 12. So when it comes to solving a quadratic inequality, okay, what do you think might be a good idea? Where might be a good place to start here with this? Yeah. We want to have 0 on one side, just like we do with our, minus 12 there is greater than 0. Okay? Yeah. I'm going to rewrite this this whole thing because I don't like having that little dot above it there. Okay. Very good. Okay. Now again, let's think about what this thing is trying to ask here. Okay, it's asking when is this greater than 0, okay? Or graphically speaking, we want to know when this is above what? Well, and we're at 0 here now. Well, the quadratic is either always above its vertex or it's never above its vertex, depending on whether it's open up or down. So yeah, what would 0 represent graphically here? If this is our quadratic, and we want to know when it's greater than 0. Not the vertex, the y-axis. Well, not the y-axis, sorry. The x-axis, right? Okay. This, right? This function here. We want to know when it is greater than 0. When it's when. So Daniel, and maybe you meant like so when it's y is 0, which would be the x-axis there. Yeah. Okay. So we want to know when this thing is going to be greater than 0. Okay. Well, what can we kind of like already determine just from looking at this quadratic? What kind of parabola are we going to be dealing with? Is it going to be like the u kind or like the upside down kind? Is it going to be the u or the upside down? U. It's going to be the u, right? What gives it away? Yeah, we have a lead coefficient that is positive there. Okay, yeah, we have a lead coefficient that's positive, so we're going to have that kind of positive parabola, I guess. Whatever. So that means if we think about this here, all right. So if I just like sketch this just do a little quick sketch of this, what could happen, right, is we could have like 3 different situations. Either we could have a u like this, we could have a u like this, or we could have a u like that, right, that comes down and just hits once. Okay. For this first situation, if we have this situation, right, what will be our solutions? All real numbers, right? Because this is always greater than 0, right? It's always above. It's always greater than 0. What will be our solutions here? Everything left of this 0, right? And everything right of this 0, right? Because to the left of this 0, we're positive, and to the right of this 0, we're positive. Okay, so we could have then two inequalities that are kind of going different directions there. And then for this one, what would the solutions be like for this one? When is this parabola greater than 0?
All real numbers except one number.
Yeah, all real numbers except whatever that vertex is right there where it's touching. Okay, exactly right. All right. So we don't have to necessarily, well, I guess what I should say here is, never mind, let me back up on that. So either it's all real numbers, it's going to be all real numbers but one number, or it'll be, to the left of this 0, to the right of this 0. So to figure that out here, what might be helpful to try and find? Find the zeros, right? Let's find the zeros and see what we've got. All right, so we're going to do that by seeing if this factors or using the quadratic formula, either choice. But let's see if it factors, right? So I'm going to try and factor this. So let's see here. I need 2 numbers that multiply -12 and add to 5. So I think like 4 and 3 are going to be where it's at here. Plus 4 minus 3. Okay. So then our zeros, I'm going to say it's equal to 0 here in this case, and set this one equal to 0, just because we're just trying to find those zeros. 3 halves and x equals -4. Okay. And so again, because we know our parabola is like, one of those positive parabolas, positive a value there, and we have these 2 zeros, if I wanted to do a quick sketch of just our answers on a number line, okay, for the x values that would work here. Well, first of all, are we going to include the -4 and the 3 halves? No. Why not? Right, this inequality here, folks, doesn't have an equal to, right? And so these zeros, these are zeros. This is where our quadratic is 0. That's why they're called a 0, right? And so we're not supposed to count those. So we're going to do open circle, okay? And then again, because our parabola is a positive parabola like this, we're going to go to the left of our left 0. So this is the left of -4 will be our solutions. And then to the right of our positive 0, 3/2 there, or the rightmost 0, I guess. And so there's our solutions. Okay, there are our solutions. Okay, without having to do too much work, or very similar work to what we've been doing. Now, if that's confusing, if that kind of analysis is confusing to you, okay, another thing you could do is get your zeros again, but this time just test numbers in your interval, okay? So for example here, what would be a number in this interval that we could use to test? Sure, -8, -5, -10, -1,000,000, whatever you want to put in. Plug it back into the quadratic. If it makes this inequality true, that means you have solutions in this direction, okay? You could also test a number in this interval. So what would be a good number to test in this interval?
0.
Yeah, 0. Plug 0 in. I'll just do it real quick. 0 plus 0 minus 12. Is -12 greater than 0?
No.
Nope. And guess what? We didn't include that interval. And then this interval, you could pick, 2, 3, 10, 100, whatever. Plug that in. Is it greater than 0? If yes, then you shade in that direction. Okay, include that interval. So that's another way to do it if you don't want to have to think too much about trying to picture the graph in your head. But I figured I would at least give you guys an opportunity to think about just picturing in your head too. Okay? Questions on any of that? Or did you try one on your own here? All right, so you guys try this one here. Okay, so x squared plus 2x plus 4 is greater than 0. Okay, again, solve for all values of x. Okay. I think I'm going to try and give you another one here too. Let me see if I've got another one that's good to go. Yes, I do. Okay. So try this one, and then also try this one here. X squared plus 2x plus 1 less than or equal to 0. Okay? And I'll try and leave up that other part there, especially for now. She just got back here. There we go. So try those two, and then that's it. We're done for the day. Okay, let's go these. And again, if you get stuck on one, feel free to, try a different one. Try the other one there. will say that both of us that's a cough for me. You need a drink of water or something like that? Yeah. It's like got trains and stuff like that. Yeah, I hate that. Both 1 and 2 here, folks, are a little strange, I will say. They're both a little bit different than that first one that we did, okay? They kind of cover the other 2 scenarios that I was just talking with you about in that picture there. So, yeah. So just a heads up, but I'll again work my way around here.
I think I've got 2.
The second one or both of them?
Second one.
Okay. You want me to come take a look at it?
Yeah.
All right. Let me see. Okay. And
The other 2 didn't work.
yeah. Okay. So I think it should be okay. -1. I got you. Okay. Did you test the other side of this too? So you said x is greater than or equal to -1 works, right? Did you test on the other side too? So did you test for x's that were less than -1 and see if they worked too? So check them. They didn't? -2? Let's see here. -2 squared.
-2 squared is 4 minus or plus 2 times -2. That's -4. That's 0.
Plus 1.
Plus
Is
1
not less
is
than
not
0.
less than equal to
Okay.
0.
There you go.
So yeah, I thought it was right.
Okay.
So I got that one totally right.
Well, did you test x value that was greater than or equal to -1? So did you try like 0?
I tried 1.
Okay, and what does 1 get
1
you?
squared. Wait. Is there no solution?
Well, there's not no solution here. There's one solution that's going to work.
Is it -1?
It's -1. Oh, on the dot. One solution.
I messed up.
Well, these were a little bit trickier too than the ones I showed. The one that I showed you there. So.
Yeah, I got that one right.
You'd be like, 1 more minute here, 1 more minute, 1 more minute. 1 more minute. I also have cups too, if you want to get a cup of water, bring it back with you or something. Okay. Rohan, what'd you come up with here? Did you get 1 or 2? Okay, 2 is one solution. Okay, so how did you arrive at that conclusion? What did you do here?
So I basically factored it.
Factored it.
I got 2, like for x is equal to -1 for both of them.
Yeah. Okay, yeah. So yeah, we got -1, and then you're like, well, x equals -1 definitely gives me a 0. And then on our number line, did you try and test to see if anything to the left or right of -1 works?
Yeah, I tried 0 and then
Okay. Yeah.
Okay, you want chocolate chip or M&M?
Chocolate chip, please.
Okay. Chocolate chip. Thank my mother for that.
Oh, thanks, Jenna's mom.
I was just like, Mom, I gotta get a cookie for Mr. Woodmeyer. Go steal that for me.
Thank you. Okay, no worries. Thank you, Jennifer.
He asked.
You asked him.
No, he's bringing me back a snack if they're giving.
I asked her to, yeah.
So I was like, okay, I'll try.
Mr. Witt knows when snacks might be available, so
They're always available.
always available. So anyway, if we test here, back to what we were talking about here, Rowan. If we were testing, okay, if you checked over here, let's try -2. -2, you plug that back in, it won't be less than or equal to 0. If you try 0, it won't be less than or equal to 0. There's only one solution, and it's x equals -1. That's it. So the scenario here, is we have a parabola that is positive, and that parabola comes down, just touches the x-axis, and goes right back up, right? Graphically speaking here. And so the one place where the parabola touches the x-axis and is equal to 0, that's the only place that satisfies this inequality. Otherwise, it's all positive and never less than. Okay? So that's right. That's exactly right. Just one solution. Kind of weird, right? All right, let's go to Tommy. Tommy, did you get number 1?
Not really.
No, oh, so can you at least run me? Did you try it? Did you get any? Did you get? Okay, yeah, that's actually exactly what you want to do here. And when you did the quadratic formula, what'd you end up with?
I don't know. I did it right.
I think you might have. Okay, seriously. So let me just set it up here. -2 plus or minus b squared, so that'll be 4 minus 4 times 1 times 4, so minus 16. All over 2, like that. 2 times 1, 2. That's what you got. What does this result in? What are we going to end up with? That 4 minus 16 is going to be negative, right? So it's, yeah, imaginary. Yeah. So we're going to end up with these imaginary solutions. There's no zeros. There's no zeros. But does that mean there's no solution to this inequality? So no zeros, think graphically here, okay? Think visually, right? If you don't have any zeros, that means either we have a parabola that's doing this, or we have a parabola that's doing this, right? So Tommy, which one is it? Is it the top one here or the bottom one here? It'll be more the top one. What gives it away that it's this one? What gives it away there? That that's the way, and it's not this. What's positive? Yeah, the a value there. Yeah, the a value is positive, okay? It's positive, okay? So, if we have this kind of scenario, not this, when will this graph be greater than 0? When is this graph greater than 0?
All the time.
Yes, thank you. I was whispering. Okay, but it is. It's all the time. That's right, okay? So this is x, I want to say, actually I'll just say x is all real numbers. Okay, any number you plug in for x will be greater than 0. How do we draw the number line to test it here? Well, in this case, since Tommy wasn't able to find any zeros, and none of us were, right? There aren't any. Just you pick any number on the number line and test it. 0, 1, a million, pi, e, whatever you want to pick. Plug it in for the x there, and if it's greater than 0, well, then you know the entire interval works. And if it's not greater than 0, then you know the entire interval does not work. Okay? So x is all real numbers. Okay? If you want to make it easier on yourself, you can say x is an element of the reals, like that. That's another way to do it. Okay? Different way to write it. Same thing. That's more mathy. Okay? Questions on any of that? All right. For those of you that weren't here, I'll get you, I'll redo everything real quick, but I want to get them started, on their work since they're ready to go. So, okay. If you are ready to go, your homework is already posted to Google Classroom. I'll put it up here on the projector for you so you can see. Both of them are out of the book. One's in the back of the book and one's, earlier in the book, obviously.